Hi and welcome. This is Martin and Susanna's group 10, and we have this limits we're about to tell you about. We have this problem here, and we're going to go through it in 3 steps. So the 3 steps are that first we will substitute x with 3 and see what happens, and then we'll take it from there and you will see what happens. And so let's go. As you see, if we substitute this with x, we get 0 over 0, which is not so good. You can't divide stuff by 0, so it's not defined in that point, x equals 3. So what do we do? Because we want to figure out what that point actually is, that value, the y value of x equals 3. So we redefine the function, and we do that by, we take our function here, x squared minus 6x plus 9, x squared minus 9 over x squared minus 9. And we take this, and then we say our numerator is actually, if you look at these, you can see that here the numerator and the denominator, there might be something that cancel each other out, but the way the form they are now, it's not going to do that. So if we show you a way to do that. And it's pretty simple, because we can just look at the sentence here that we know from school, that this part here is pretty much equal to this part, or it is, and this part is like this, and so on. And so that gives us, like you can see it here, actually, right? So this part is this, and this part is that, and this part is this. So we can just replace that. So we get minus 3 here, we get minus 3, and we get x and x, and if we multiply it backwards, then we'll get this. So it adds up. That's the numerator. So we can do the same with the denominator. And here's just another rule we have to use. And you can see here, this value is the same as this one. It makes total sense. Just zoom out a bit. And there you can see how it makes sense. Good. So now we just plug it back in. So we have our numerator and our denominator here, right? You can see it's the same ones. So it's pretty simple. So now you can already see that stuff starts to cancel each other out. We get that here. Okay, so we have our new function here, or this one actually, and now we're trying to find the limit of that when x goes towards 3. And this is how it looks. So we substitute x for the redefined function, basically. And we put in 3 minus 3 and over 3 plus 3, and it gives us 0 over 6, or 0 in other words. So the value, the y value, or the function value, is 0 in 3. So there was a hole there in that part of the curve, in the graph. So now it's, with this function here, it's continuous in that point. So it's actually filled out. To sum it all up, what we did was let's just see again here, right? We went through step 1. We substitute, that's the first thing we do, with x, and we find out that it doesn't work, right? So the next thing we do, we redefine it, and we do that by using our rules, these ones, the red one. So we don't have that 0 in the denominator anymore. That's what it's about. Yeah, we go on. And then we cancel things out, so we can substitute x again without having the 0 in the denominator. And then we just let x go towards 3. We substitute x for the redefined function, as it says there, and we get 0. So that's actually all there is to it. So in the end, the limit of the function is equal to 0. That's the number that is getting approached from both sides. So that's it. And thank you for watching, right?